All right, if you look at this one, B&W Leather wants to make belts that they get 18 bucks a piece profit and wallets in which they get 12. The belts require 2 hours cutting time and 6 hours sewing time, and the wallets require 3 hours cutting time and 3 hours sewing time. If the cutting machine is available 12 hours a week and the sewing machine is available 18 hours per week, what's the mix of belts and wallets that will produce the most profit with these constraints? All right, so what we have here, let's let X, let me move this back up here, okay. Okay, one more time here. I gotta hit cancel here first. Okay, let's let X equal belts. Let's let Y equal wallets. Okay, now if you notice, we can go over here and go f of xy, and we know that we get profit, we get $18 per belt, plus we get $12 per wallet. So that's going to be our function for this linear programming problem. All right, we know these things as well. We need 2 hours of cutting time for the belts, plus we need 3 hours cutting time for the wallet, and that's got to be less than or equal to 12 hours because that's all the machines available for the week. Okay. We also need 6 hours sewing time for a belt, plus we need 3 hours sewing time for a wallet, and that's only available 18 hours, so that's less than 18. And of course, we're going to be making some belts, so X has got to be greater than or equal to 0. We're going to be making some wallets, so Y's got to be greater than or equal to 0. So our goal here is to find out how many different combinations of belts and wallets we can make so that we can maximize our profits. So we want to max these profits. Okay? That's really our goal when we do this. Okay? So let me erase all this so we can study this up. Okay. So now if we get on here and make a nice XY chart, okay, something like this, I'll change colors. We know now that everything above this and above this, we're going to be in this region. So X is greater than 0, Y is greater than 0. So we're going to be in the first quadrant. Okay? All right, so let me rewrite these. So we're going to have up here 2X plus 3Y is less than or equal to 12. And then we're going to have 6X plus 3Y is greater than or equal to 18. And then I just did X is greater than or equal to 0 and Y is greater than or equal to 0. So if I go ahead and graph these, first thing I'm going to do is, all right, let me change colors one more time here. If I solve this first equation, this is going to give us Y is less than or equal to negative 2/3 X plus 4. That's our first equation. If we solve this one for Y, we're going to get Y is less than or equal to, and this of course will be negative 2X plus 6. Alright, so that's our two equations we're dealing with here. So let me go ahead and erase some of this stuff so we can get this out of the way. Alright. Alright, now what I want to do is, let me move this over here. I should have did this to begin with. Okay, so Y is less than or equal to negative 2/3 X plus 4. And then Y is less than or equal to negative 2X plus 6. And again, let me get rid of these. I should have never put these over here. That's where we want to do our graph. Alright, so let's go ahead and graph this first one. Let me change colors here. Alright, so this first one's going to have y-intercept of 4, so let's get 1, 2, 3, 4, something like this. Okay? And it has a x-intercept of 6, so let's get 1, 2, 3, 4, 5, 6, somewhere in here. Alright, so it looks something like this. This point here is, of course, going to be 0, 4, and this point down here is going to be 6, 0. Okay, so that's this graph, okay? And then this one has a y-intercept. I can change colors here again. Let's go to yellow, see if that works. So this one has a y-intercept of 6, which is going to be up here. Okay, and it has a y-intercept of 3, which is going to be right about here. Okay, we can connect those two, something like that. Alright, so now we have a bunch of points we can consider here. Of course, we know that this is going to be the origin. So this is going to be 0, 0. This point up here is going to be 0, 6. We're not really interested in that because it's not bound. Okay, 0, 6. What we are interested in is in this point, which is 0, 4. And of course, this intersection point here, with a little bit of work, this intersection point, I'm just going to give it to you. It's going to be 3/2, comma 3. And in this point in here, it's going to be 3, 0. Alright, I know that got kind of crowded here. Let me clean this up a little bit. Okay, so now, let me change colors of that. We're going to be interested in this area right in here. Okay, right in here. Okay, so right in that area right there. Okay, so now I'm going to erase this over here, try to fit this all on one page. So here are our areas. So here's our points. So we want 0, 0, 0, 4. We want 3/2 and 3. And then the last one here we want to consider is going to be 3, 0. Okay, so that's those 4 points that we need to look at. Alright, so I'm going to go ahead and erase all this stuff. We'll get this all out of the way here. Yeah, maybe. Here we go. Alright, so let's get that all out of the way. Alright, here's our original equation. So this is going to be f of x, y. This is going to equal 18x plus 12y. So let's go ahead and do the first one. This is going to be 0, 0. That one's easy, no profit. Next one's going to be f of 0, 4. So this will be 0 plus 48. That'll give us 48. Okay. Next one's going to be f of 3/2. Oops, I messed that up. F of 3/2, comma 3. So, alright, so this is going to be 18 times 3/2 plus 3 times 12, which is, of course, 36. This gives us 9 times 3, which is 27. 27 plus 36 is going to be 13, carry my 1, $63. And then the last one is going to be 3, comma 0, which will be 3 times 18, which is 54, plus 0, which is 54. So as you can see, let me change this to a nice yellow. So you can see right in here, if we sell 3.5 belts to 3 wallets, we'll make the maximum profit. So for every 3 wallets we're going to make 1.5 belts. And that's just kind of the way it works out for our maximum profit of $63. Thanks a lot. Again, this is on YouTube if you want to watch it again, and it is called B&W Leather Company. Thank you and have a great day.